I'm Colin Sandeman. I'm an integrated construction coordinator at Mortenson Construction. Today I'm going to show you guys step by step how we get our design team model into the VR headset. So right now what we're looking at is the whole composite Navisworks file of the Vikings Stadium. So you can see this houses all the design team models, all the subcontractors models. So there's probably over 150, 200 models housed within Navisworks. So you can see just the complexity within this model. So we use this for coordination purposes, not for visualizations, but this is a good program just to kind of isolate what areas we want to see and what problem areas, whether it's coordination with ductwork and walls or any circumstances that we need to find a solution for. So you can obviously see if I jump over to the locker room, this is what the locker room looks like within Navisworks. So there's ductwork flying everywhere. There's no materials. It's pretty flat. You can't really get a good sense for the space. So what I did was, this is the design team's model. So it's all exported from Revit. And what I did was I basically highlighted the area that we wanted to fully visualize and add textures and materials. Open that in Revit, create a section box, isolated that and imported it directly into SketchUp. And this is kind of how it came in. So you can see that I didn't hide some structure, but essentially all I wanted from the design team's model was just the bones of it. I would keep the walls, the space. You can see that there's lockers in here. There was the Vikings Norseman head in here that I did keep. But like I said, we're just kind of focusing on the bones of the space. The Revit model is not designed for VR, and it's not even designed for just straight visualizations. But this is kind of where we left it. Put all the materials on. I tried to match everything the way the design team picked out. So this probably took, throughout the process, it probably took a month, but that was just because we went through so many different design changes. But then when you go from SketchUp into VR and you put the headset on, you can now walk up to the lockers and you can say, whoa, well, these lockers are way too small. Or is this really how the carpet's gonna look? Because it looks horrible. There's just something about looking at a space three-dimensionally and then experiencing a space, which is crazy, I think. It's something that you think that you put the headset on and you're just gonna be looking at a screen like on the computer, but when you can actually feel the presence of materials and lockers and get a sense of lighting, I think that's really when you can really start to understand that maybe some of the designs weren't exactly what you envisioned, even though they look good on screen. Once you actually experience them, they sometimes are exactly what you want, and other times you just scrap the whole thing. And that's what we kind of ran into with specifically the carpet and the lockers. So we take the design team's Revit model, isolate the particular space. So for this instance, the locker room, import that DWG into SketchUp, And this is that base model that is directly imported from Revit. So there's no materials. Once I get this model, then I start cleaning up all the different geometries. So I would hide a lot of the stadia, a lot of the walls that you would not see. I'm basically just using the bones and the structure of just what you will experience in VR. So everything outside of this locker room would be hidden. Within SketchUp, I clean up a lot of the geometry and then materialize all the walls based on what the design team has picked out. And that process is usually a longer process, just because SketchUp is so nice that you can switch back and forth between different materials, and you can show the design team, well, this is the type of granite that you've picked for the locker. Well, let me see what a green or a purple looks like. So within SketchUp, it's running through all those different options. And then once we've picked and finalized those design options, that's when we're ready to experience in VR. So SketchUp to Unity or Unreal, the workflow is so much easier now. It's honestly, it's a file, export, 3D model, and then FBX. It directly goes from SketchUp FBX, it carries over all those materials, and then within Unity, you're basically adding lighting, baking lighting into those materials, and then just changing reflections and adding glossiness or bump maps, just to really, I guess, show a much more refined space. So after I export my FBX from SketchUp, all I do is I fire up Unity, start a new project. I go over to my assets, and it's 2 clicks. It's import new asset. I select my new FBX that I just exported from SketchUp. It'll load directly into Unity, and all I do is I click and grab and I throw it into the space. And we're ready to start adding lighting. So it honestly, from SketchUp to Unity, is like 4 clicks. It's exporting an FBX, importing the asset into Unity, dropping it loading the FBX into Unity, and then dropping it into the space. So now within Unity, now this is really where you can see that all the materials have came in, but there's really no lighting. You can also see that the materials are all pretty flat. So this is where I would go in and I would select different materials and add bump maps, bump up reflections, or add some glossiness to whatever material that I'm working with. But just for a little walkthrough, I can just drop in a couple different point lights and spotlights, just to show. So yeah, there's 2 different ways to do lighting. You can do lighting within SketchUp through LightUp. So within LightUp, you're essentially just dropping lights in, much like you would in Unity, but you're baking those lights within the materials. And then once those light-baked materials are done processing, we take that model and drop it into Unity. So you're not adding any lights within Unity. Those light-baked materials are already transported into Unity. So that's one option. The other option is to do all of your lighting within Unity. So it's a little bit more of I would say, intensive process, but you have a lot more functionality with materials. If you do the SketchUp plus light up route, the light baking, you have no real mobility to add a whole lot of, I'm really big into adding bump maps and reflections. So when you're walking around the space, you really get a good idea of how, objects interact with light. So if you go the Unity route, it takes a lot more processing power, but you have a lot more functionality with using a whole different array of lighting and material options. It's an incredibly easy process because we used to have to totally publish and build before we could even see the space in VR. Now, the VR is built into Unity and Unreal, where you can test your space before you package everything together. So there were times in the past where you would package something together and you would think that it was ready to go, and you'd walk around the space and materials would flicker, or lights wouldn't be showing up properly, or materials wouldn't be showing up. So the ability to preview your VR scene just in the build mode in Unity probably cuts down the time to publish or get to that final end in half the time. So that's probably the biggest thing that they've implemented that has helped us a ton. Mm-hmm. Just being able to throw on the headset and just preview your space before you're really ready to build and show it to somebody. Now that we've created the space, added the lights, now we just need to add us into the space. So that's what's called a first-person controller. So it's just like, it acts essentially just like a light. It's basically drag and drop into the space. So once we drag and drop our first-person controller, that's where we can start, hit our play. So drop in our first-person controller, and all you have to do is hit play, and then you're ready to walk through your space. So this is something that we would do thousands of times probably before we actually build and package the full project. So the ability to walk through your space before you send it off, and even the ability for someone else to walk through the space to get their input saves us so much time, and it really helps facilitate the design process. Unity automatically detects that there's a headset plugged in. So if that is plugged into your computer and you hit play, it won't go into your first person on your screen mobility. It will automatically jump to the Oculus or the Vive. Now it's literally plug and play. Mm-hmm. You create your space, you plug in your Oculus Rift. When you're ready to preview your space, hit play. It automatically goes to your headset, and you're ready to review. So once the space has been reviewed, it's ready to go out to our customer. It's very simple to publish and package the project. It's a file, build and run, click. There's a dialog box that lets you decide which platform you want to export it out to. Default is PC, that's what we'll do. Build and run, we'll save our executable. And then it builds a scene. The reason why the run and build, we build an executable, is that executable can now be passed to anybody that has a VR headset. So all they have to do is double click the executable and it goes directly into their headset. So We do all the hard work within Unity. It packages it together, it creates an executable, and then we can now distribute that executable to anyone that wants to either walk through even without a headset or with a headset. So